Thermal energy enters a common mineral. A localized thermodynamic deficit is instantly generated. You apply 90 degrees of heat. The surrounding environment registers a severe temperature drop. The thermal inversion extracts enough energy to freeze water into solid ice. It requires raw sunlight. It requires industrial waste heat. The system functions without mechanical compression, without fluorocarbon refrigerants, without electrical current regulating the thermal exchange. The mineral is zeolite. This is categorized as a laboratory hypothesis. It is not a laboratory hypothesis. It is an active commercial mechanism. Complete buildings achieve exact temperature regulation through this material. Solar thermal radiation drives ice production in hyper-arid deserts. Solid-state physics applied in concrete reality. The mechanical simplicity was systematically marginalized. The thermal conversion demands precise explanation. The industrial abandonment requires objective analysis. The physics of generating a thermodynamic deficit without a compressor predates the compressor itself. The foundational mechanism relies on an extreme molecular reaction. Specific material matrices generate intense thermal output when saturated with atmospheric water vapor. The electron flow reverses. The temperature plummets during molecular desorption, a rigid physical certainty. The general population remains unaware. You likely possess a machine operating on this physical principle. Specific modern dishwashers contain a dedicated internal compartment. It holds exactly 1 kilogram of this precise mineral. During the primary cycle, the matrix forcefully extracts atmospheric moisture. The hydration generates intense internal heat. The system discharges that stored thermal energy during the final cycle. It vaporizes residual water on dishes. It requires 0 electrical heating elements. The mineral executes the thermodynamic labor. It trades water molecules with the immediate air, a silent thermal transfer. The mineral belongs to a specific chemical family. Industrial engineers at the Fraunhofer Institute have studied this framework for a century. The molecular mechanics enable a massive thermal inversion. A material captures water vapor. It discharges thermal energy. You reverse the sequence. You generate a severe temperature deficit. This phenomenon is defined strictly as adsorption refrigeration. It is not a modern development. The architectural deployment runs parallel to early industrial refrigeration. It originated in the exact decade that birthed mechanical cooling systems. The foundational physics remain perfectly unchanged. The framework shares a thermodynamic lineage with the phase change ammonia coolers previously documented. The mechanical architecture is similar. The physical state is entirely different. A circulating liquid does not execute the thermal transfer. The molecular exchange occurs completely within a rigid solid structure. The solid matrix provided structural engineers with a severe mechanical advantage. The absolute capacity to generate a thermal deficit using shear heat. It operates without a rotating compressor. Without an electric motor driving the sequence, it requires only the mineral structure. Liquid water. Baseline thermal input. Researchers constructed solar-powered refrigerators utilizing this exact principle. Solid ice forms under direct ultraviolet radiation. Industrial technicians constructed massive climate control systems. They captured thermal exhaust. They forced waste heat to regulate interior temperatures. The application was absolute. The thermal exchange functioned flawlessly. The core sequence relied on one specific geological formation. It executes the molecular transfer with unmatched efficiency. The mechanism requires strict structural analysis. The material is designated as zeolite. To comprehend the thermodynamic power, you must analyze the spatial geometry. The physical volume consists almost entirely of void space. Zeolite is classified as a microporous aluminosilicate. The chemical structure comprises aluminum, silicon, and oxygen atoms. The crystalline framework occurs organically in precise geological zones. Volcanic ash interfaces with alkaline groundwater. The synthesis requires millions of years. Industrial laboratories also manufacture the material synthetically. The geometric lattice is fabricated with absolute microscopic precision. The efficiency does not derive from chemical composition. The power originates entirely from the geometric configuration at the microscopic scale. The crystalline structure is highly porous. It is honeycombed with billions of nanometer scale channels. An immense internal labyrinth dictates fluid dynamics. The mathematical reality demands strict attention. The internal voids dominate the structural volume. The hidden surface area inside a singular crystal completely defies standard spatial logic. You extract exactly 1 gram of the material, a mass small enough to balance on an index finger. The internal geometric surface area exceeds 500 square meters. You extract a standard tablespoon. You unfold the microscopic planes. The total surface area drastically eclipses the floor of a large commercial room. Each nanometer of that geometric plane possesses extreme electrostatic attraction. It violently strips vapor directly out of the atmospheric column. This specific geometry renders zeolite an extreme desiccant. It represents the absolute limits of moisture absorption. It shares a molecular lineage with standard hygroscopic compounds. It is a structurally superior relative to the desiccant salts previously analyzed. Standard calcium chloride extracts atmospheric moisture. The crystalline structure destabilizes. It collapses into a liquid brine. Zeolite operates differently. It forces the vapor molecules deep into the nanometer voids. The rigid electrostatic hold is mathematically severe. The physical structure never loses integrity. The general consensus completely misinterprets the mechanism. The separate materials exhibit superior thermodynamic function when forcefully combined. Materials scientists execute a precise synthesis. They impregnate the microporous zeolite lattice with pure calcium chloride. The exact salt structure previously detailed. The extraction parameters exceed the baseline capacity of raw zeolite. The crystalline solid and the hygroscopic salt fuse. The resultant structure is thermodynamically aggressive. A powerful desiccant is merely a chemical reality. Converting that molecular attraction into a severe thermal deficit requires mechanical execution. The generation of solid ice, via vapor extraction, demands strict observation of the liquid state. The physical sequence requires absolute focus. The explicit operational parameters of salt-based thermal reduction exist in the technical manual below. You initiate the digital transfer. You secure the document. The data enters your local server. The mechanism of thermodynamic extraction demands analysis of the fluid phase. The physical sequence is universally observable. You step out of a standard shower. The phase change of water dictates the thermal reality. Liquid water transitions to vapor. A thermal deficit is immediately generated. You expose wet skin to a mechanical fan. The central nervous system registers a severe thermal drop. The liquid barrier vaporizes. The departing molecules forcefully extract thermal energy from the biological surface. This exact thermodynamic transfer was definitively documented. The physical law is absolute. Evaporation is direct thermal reduction. Standard open system evaporation possesses a terminal mechanical flaw. The liquid transitions to a gaseous state. The localized atmospheric column absorbs the moisture. The relative humidity hits absolute saturation. The gradient collapses. The phase change terminates. The thermodynamic extraction halts entirely. The atmospheric volume reaches absolute maximum capacity. The aluminosilicate structure alters the physical parameters. You construct a hermetically sealed vacuum vessel. You inject exactly 1 liter of liquid water into the primary zone. You deposit a calculated mass of zeolite into the secondary zone. You mechanically evacuate all atmospheric gases. The liquid water instantly begins phase change in the vacuum. The zeolite exerts extreme electrostatic pressure. The internal surface area forcefully rips the vapor molecules from the void. The chamber never reaches humidity saturation. The geometric matrix extracts the gaseous vapor at terminal velocity. The saturation gradient remains infinite. The phase change is continuous. The thermal extraction is relentless. The liquid mass is physically compelled to accelerate evaporation. Every escaping molecule strips kinetic energy from the localized pool. The baseline temperature violently collapses. It passes the 0-degree threshold. Solid ice forms. The electrostatic attraction forces the liquid into rapid thermal collapse. This represents the primary extraction stroke. It strictly generates the thermodynamic deficit. The zeolite matrix eventually achieves maximum volumetric capacity. The internal nanostructures saturate with water molecules. The electrostatic gradient neutralizes. The system must be structurally reset. The mechanics demand a physical purge. You apply massive thermal energy. You inject intense heat into the saturated mineral. The energy source is irrelevant. Concentrated solar radiation, direct flame combustion, industrial thermal exhaust. The kinetic energy forcefully ejects the trapped water molecules. The vapor violently exits the microporous lattice. The gas is captured and condensed back into liquid form. The internal voids are completely evacuated. The electrostatic potential resets to absolute maximum. The solid structure is primed for immediate thermal extraction. The mechanical loop is closed. The temperature drops during liquid evaporation into the matrix. The physical parameters reset when external heat purges the trapped vapor. The thermodynamic sequence is structurally flawless. The operational query is scale. Can a geological formation regulate an entire building? The physical reality is undeniable. Industrial manufacturers fabricate massive zeolite adsorption chillers. The thermal extraction capacity is measured precisely. The units output 100 to 500 kilowatts of cooling power, a volume mathematically sufficient to regulate large commercial structures. These are not isolated experimental prototypes. They are commercial assemblies. They actively extract heat from real architectural spaces today. The subsequent data point is the critical mechanical threshold. The sequence operates entirely on heated water. The required thermal input is exactly 50 to 90 degrees Celsius. This is defined strictly as low-grade thermal energy. This perfectly matches the thermal exhaust of industrial production lines. The rejected heat of a diesel generator, the exact thermal mass industries vent into the atmosphere as garbage. The zeolite mechanism intercepts this specific thermal waste. It executes a thermodynamic conversion. It directly outputs structural climate control. The thermal input source is entirely modular. You extract kinetic energy from a diesel exhaust manifold. You capture turbine discharge. You harvest direct solar energy. The thermal energy you currently discard possesses the exact capacity to regulate your primary structure. The engineering scales down seamlessly. Specialists at the University of Johannesburg assembled solar-powered adsorption refrigerators. The units generate solid ice using ambient solar radiation. The structural tests succeeded in harsh sub-Saharan thermal extremes. A standard refrigerator operating in a desert environment. Ice production powered directly by the exact solar radiation generating the extreme ambient heat. The coefficient of performance consistently scales upward. The salt impregnation procedure accelerates the efficiency curve. The specific composite of calcium chloride and the microporous lattice achieves a measured coefficient of performance of 0. This is a severe mathematical increase over the baseline solid. Advanced synthetic structural analogs currently push the maximum efficiency to 0. The extraction core contains exactly 0 moving components. The absence of kinetic friction eliminates physical degradation. The mechanical maintenance requirement approaches 0. The physical parameters require absolute structural honesty. The thermodynamic mechanism is fundamentally heat-driven. The system generates a severe thermal deficit. The solid matrix then demands massive thermal input to reset. This is categorized as a perpetual energy loophole. It is not a perpetual energy loophole. It is the rigid application of thermal physics. It converts unmetered solar radiation and industrial exhaust into massive thermal extraction. It requires 0 mechanical actuation. The mechanism is proven. The system is fully commercialized. The physics operate continuously. The logical query remains. The physics are proven. The capacity is absolute. The thermal input is discarded energy. Why does a standard mechanical compressor occupy your residential structure instead of a zeolite matrix? Before the systemic analysis, structural thermal reduction data is compiled. The repository is labeled the Free Cooling Manual. 3 technical volumes. The explicit physics of salt cooling. 60 overlooked thermal extraction methods. Precise architectural integration blueprints. 86 validated protocols. Empirical data. 0 consumer electronics. Backed by a standard 168-hour validity guarantee. The access vector is documented below. Maintain observation. The absence of this mineral in residential architecture exposes a severe industrial calculus. The commercial implementation is reality. The mechanism operates at massive industrial scale. But the thermodynamic parameters possess strict mechanical limitations. You must analyze each operational constraint. Parameter 1 is the primary thermodynamic limit. The system is strictly heat-driven. The mineral generates a thermal deficit. The matrix then requires massive thermal input before the sequence can repeat. It does not violate the first law of thermodynamics. It requires absolute heat for the mechanical reset. Solar radiation, direct combustion, industrial exhaust. The thermal input can be entirely unmetered, but the input is mathematically mandatory. Parameter 2 is atmospheric isolation. The system demands an absolute vacuum environment. The structural vessel must achieve extreme vacuum tightness. This requires rigid industrial engineering. It is not a casual mechanical assembly. The entire molecular exchange depends entirely on that evacuated volume. The water and the matrix trade vapor in a void. A single atmospheric breach collapses the pressure gradient. The sequence terminates instantly. Parameter 3 is thermodynamic efficiency. You analyze the exact energy input versus thermal output. A zeolite matrix outputs a lower coefficient of performance than an active electrical compressor. The raw COP is mathematically inferior to competing systems. The context dictates the relevance. The mineral operates exclusively on discarded thermal exhaust or solar radiation. A standard compressor cannot utilize this energy state. You evaluate a system consuming unmetered kinetic waste against a system drinking expensive centralized utility power. Lower mechanical efficiency, utilizing free input, yields a net structural advantage. Parameter 4 is industrial logistics. The supply chain is severely restricted. The commercial assemblies possess high baseline acquisition costs. It is a rigid economic feedback loop. Low manufacturing volume dictates high unit cost. High unit cost prevents mass deployment. Low deployment ensures low manufacturing volume. The cycle reinforces itself. The thermodynamic reality remains unchanged. The industrial chillers execute the extraction sequence every single day. It represents a specialized mechanical instrument. It possesses specific operational limitations. It possesses one singular thermodynamic superiority. The mechanical limitations did not eliminate zeolite from residential architecture. The exclusion requires economic analysis. The solid-state extraction did not fail on thermodynamic merit. It failed due to centralized utility models. An alternative mechanical system was deployed. It could be enclosed. It could be patented. It guaranteed recurring capital extraction. The absolute physical advantage of the zeolite matrix was precisely its inability to be monetized. Analyze the required fuel source. Raw solar radiation. Industrial thermal exhaust. The intense heat radiating from a mechanical engine block directly into the atmosphere. The thermodynamic genius is the direct conversion of unmetered kinetic waste into a localized temperature deficit. Examine this exact parameter from the perspective of a centralized energy provider. The corporate objective is selling you a thermal deficit in perpetuity. Unmetered solar radiation is a catastrophic economic variable. Discarded thermal exhaust is a severe structural threat. An industrial empire cannot construct a recurring economic model around a device operating on a fuel source nobody pays for. A digital utility meter cannot interface with a star. The active electric compressor represented optimal industrial geometry. The footprint was minimal. The chassis was sealed. The intellectual property was legally protected. Crucially, the mechanism demanded continuous alternating current, a precisely metered flow of utility power flowing to the grid. The centralized network extracted capital for every hour of mechanical operation. A residential structure operating a compressor represents permanent economic extraction. A structure utilizing thermal exhaust represents absolute economic loss. The industrial deployment decision circumvented thermodynamic efficiency entirely. The primary variable was the mechanism of sale. The active compressor achieved total domestic saturation. Solid-state zeolite extraction was systematically diverted. It was pushed into isolated commercial applications. It was intentionally forgotten. The absolute capability to utilize discarded heat was classified as an operational novelty. A fundamental thermodynamic shift was artificially suppressed. The physics remain absolute. The suppression was incomplete. In isolated geographic zones with restricted utility access, In industrial sectors generating massive thermal exhaust, the microporous matrix continuously executed the extraction sequence. The global energy cost curve is currently accelerating. Discarded thermal mass now possesses measurable capital value. Structural engineering is forcefully pivoting back. The mineral is under active re-evaluation. The centralized energy sector will never mass produce a mechanism reliant on your discarded heat. The residential deployment is blocked. The physics are entirely real. The application vector is returning. Analyze the current operational zones. The mechanical sequence never ceased. It was merely restricted to environments optimized for unmetered thermal input. It is quietly scaling back towards standard architectural integration. Begin with the immediate domestic application. Specific modern dishwasher chassis utilize a dedicated zeolite block. It executes the terminal drying phase. The unit possesses 0 electrical heating coils. The solid matrix strictly discharges the thermal energy captured during the wash sequence. If your unit is equipped, a localized thermodynamic extraction sequence executes in your kitchen tonight. Expand the mechanical scale. Industrial manufacturers assemble high-capacity zeolite adsorption chillers. The systems regulate building climate utilizing thermal input from solar arrays or industrial exhaust. The output capacity exceeds hundreds of kilowatts. These are active structural components. They currently maintain thermal deficits in massive facilities. They operate strictly on discarded energy parameters. Pushed to the absolute limits of the energy grid, engineers deploy solar-powered zeolite refrigeration units. They generate solid ice driven exclusively by raw solar radiation. Decentralized thermal extraction powered entirely by the atmospheric column. Materials science is accelerating the parameters. The critical vector requires the calcium chloride integration. The composite matrices demonstrate severe efficiency spikes. The mass deployment threshold is mathematically approaching. The hygroscopic salt, fused inside the crystalline void, dictates the future of thermal extraction. The mechanical reality requires absolute structural clarity. Observe the ammonia cooler protocols. This is not a rudimentary assembly task. The sequence is entirely reliant on a hermetically sealed vacuum vessel. It demands rigid industrial tolerance. A localized residential assembly of a zeolite climate system is statistically unfeasible for the baseline operator right now. The optimal protocol is not a compromised garage fabrication. The protocol is strict situational awareness. Acknowledge the physical reality of the mechanism. Identify the deployment of commercial adsorption units. Monitor the industrial sector data. The localized energy cost will force the reviving mineral back into residential architecture. The mechanism is proven. The trajectory demands calculation. The projection requires binary analysis. Current operational status. Future deployment vectors. Both datasets are strictly critical. The current operational status is mechanically severe. A fully commercialized thermal extraction system exists. It contains 0 kinetic components in the primary core. It utilizes raw solar radiation and discarded thermal exhaust. It regulates complex architectural structures today. It forces water to freeze in arid desert zones. It requires 0 fluorocarbon chemical suppressants. Without mechanical compression, without electrical current executing the primary sequence, the pure thermodynamic achievement stands as a monument of modern physics. The deployment vector is expanding. The centralized energy grid is structurally expensive. Discarded thermal mass is a verified economic resource. Industrial laboratories are aggressively scaling the salt-impregnated zeolite matrices. This is an active technological resurgence. It is not an obsolete mechanical footnote. It is a suppressed physical method asserting dominance, accelerated by modern materials science. The crystalline structure will return. Analyze the foundational mechanism. The thermodynamic parallel remains constant across every analysis. The severe temperature deficit always existed inside a basic geological formation, available to any system with discarded thermal exhaust or direct solar exposure. The structural capacity to convert rejected heat into exact thermal extraction was a permanent physical law. The industrial marginalization was a strict economic calculation. A corporate entity cannot attach a utility meter to the sun. A centralized utility cannot extract capital from thermal exhaust you already generated. The rejected industrial heat possessed the exact capacity to cool the structure. The solar radiation was mathematically constant. The lone variable in the equation was the centralized extraction of capital. The system was replaced by a mechanism demanding a perpetual monthly invoice. If this precise mechanical analysis is required, if reducing dependency on a centralized utility meter is the objective, you must integrate with this database. The structural thermal analysis continues. The centralized extraction methods are fully documented. The SALT protocols, the localized thermal techniques, the exact architectural blueprints. All data is contained in the thermal extraction manual. The access vector is below. The algorithm has calculated the exact subsequent data file for your parameters. Initiate the transfer.